without further ado, I have a couple of additional, three actually, panel members to join us. But first, I'd like to invite Haresh to come back up and join us here at a panel. And I also like to invite the audience to think about some questions you might like to ask, because I'd rather hear your questions than mine. So the first gentleman I'd like to introduce is Ashok Nanga. Where's Ashok? Here he is. Okay, he's engineering technical lead at 3M. And thanks for joining us. Okay. Second person I'd like to introduce is Mike Bell, who's a principal application engineer for Nova Chemical. Mike? And last but not least is Ed Henske, who's a senior instrument and controls manager for Solaris Management Consultants. Thank you all. So is anybody thinking about questions you'd like to ask? Okay. Well, let me start off with a couple of quick ones. And what I'd like to do first is I'll start with Ashok. Can you introduce your company a little bit and just a little bit about, maybe you could make a comment or two about what is the top challenge that you're seeing?
All right. So good afternoon. My name is Ashok Nanga and I work in 3M company. And I just completed 36 years in 3M. So my role is to advance technology and transfer those technologies into 3M manufacturing and then communicate those technologies globally to make sure we are making comparative advantage. So, and then Dick said I should, so let me talk a little bit about my company. 3M is a $31 billion company, and we are one of the Dow 30 company. And we have 79,000 employees in 70 countries, and we have 46 technology platforms. We have 5 businesses. Industrial business by far is the largest, over $8 billion worth of business. And we have products like from 3M filters for liquid and air filtration. And we operate in aerospace and automotive industries. Industrial tapes and abrasives are well known for our excellence. Then our second business is consumer business, and you all have probably used Post-it notepads. Even after 40 years of this product, we still command over $2 billion worth of sales. We have sponges, and then our third business is electronics and energy, and that includes like your privacy film on your computer, or optical films on your television. There wouldn't be any television early on in the flat TV without our brightness enhancement films. And we still command that market. Then we have healthcare business. It's about $3 billion worth of business. And we have many products, including surgical drapes and so on. And then the last business is safety and graphics, in which we have respirators everywhere. You know, we sell respirators for different types. And then graphics business is about highway signs and so on. So those are, you know, different products we have. We have 60,000 plus products. So that's about my company. And about me, I said I have 36 years of experience in engineering and particularly in automation. So I guess we are talking today what are the automation challenges, but I want to take you back through the journey that we always had challenges and we always have overcome them. When I started, my first project was about hardwired relays to make the logic. And then there were push button panels with semi-graphics to show the graphics, and light will light out showing you how the process is moving. And by the time you design and start up the project, your semi-graphics is already obsolete. So we lived through the days, then we came with the programmable logic controllers, and everything was easy to program and do timing, counting, sequencing, and you know, life was good. And then we came up with the operator interface, and they were proprietary hardware and proprietary software, and came TDC 2000 from Honeywell, and DC Square from Fisher Provox, and they were again proprietary hardware, proprietary software, and the cost will be $1 million. And you will attend 6 weeks of training before you draw a line. So we went through that, and then came PC-based process control, and everything became easy. And then again, we were vulnerable because it's DOS-based, it's not reliable, because what the old system was proprietary but very reliable, now the new system was very unreliable. And I think everything went, I think all of you have gone through the misery of, DOS Windows and so on. And then now we have PC-based running our manufacturing very nicely. We have over 20,000 of those running our manufacturing totally connected. So this challenge continues, and I think we have always overcome our barriers. So I wanted to just, my experience has gone through that, so that's my experience.
Well,
so now you asked me the last thing about our 3M challenges. So if you look at our 3M vision on manufacturing, it means highly connected industrial enterprise to enhance productivity for our operations. So when I look at 3M manufacturing challenges, number one, we want to address design for manufacturability. And what that means is we want to address the cost, quality, speed, yields, to make sure that our cost of good is less so we can generate more revenues. The second thing is we are looking for smaller volume, fast and flexible manufacturing with quick changeover. And that means we are looking because we want to make customized product with low volumes, and we want to make low volumes in third world countries where the demand is a lot less, but they do need products. And the last thing is about sustainable manufacturing. That means we want environmentally friendly manufacturing, addressing the energy aspects and the water usage aspects, because in third world country, these things are very scarce and very expensive. So our processes have to support that. So just to address these three challenges that I mentioned, the automation challenges are, we are definitely looking for totally integrated manufacturing, no islands of automation, information is seamlessly available wherever it's needed to the people like process engineers, product managers, plant managers, and the business people. So the other thing is we are looking for industrial analytics. We are looking for a lot of data to be converted into reports, into dashboards, like if you're looking for operational equipment efficiency or energy consumption or production, we should be able to see that in a very user-friendly way where it is, so we can take action. The third thing is we are looking for technology, IT technology enabled. We hear about mobility on the plant floor, but we would like to see suppliers to build some applications to really show us how to use mobility on the plant floor using your tablets and cell phones, and how you improve your productivity. And the cloud technology, again, at the end of the day, they need to be cost justified. So how you extract that data and how you use it economically. And finally, about modeling and simulation. We need those software to not only in the concept design, but on scale up and also on model-based control. Now that computing power is very low cost, there is no reason why we cannot have much tighter control using model-based control at a lower cost. So these are some of the challenges that I would like to mention.
Well, thank you, Ashok. That sounds like it's very simple. You got all the answers out here. No, seriously, it's a major challenge. I'm glad you talked us through the beginnings, because we all can remember what those were like, I think. I'd like to ask Mike to give us a little bit about his company and a point about what's challenging for you.
So I'm Mike Bell. I work for Nova Chemicals, a Canadian company. looks like I forgot to send my picture. Actually, I didn't want it shared on the cybersecurity issues, so I just decided not to send my picture out. But I'm NOVA's principal advanced process control engineer. NOVA itself is generally a polyethylene and ethylene company. Our two main plants are in Red Deer, Alberta, and Sarnia, Ontario. For me, the automation challenges, I'm going to we certainly have all the ones that all these other industrial plants have. We're similar. I'm going to talk to it from probably an advanced process control point of view. For those ones there, it's all of those modeling kind of issues. And it's all about getting them out faster, better quality. I also am involved in the kind of that data visualization part of the aspect for our company, and so trying to get, I'll call it data into information so that that goes up to the right people so they can see what's really going on in the plants.
Thank you, Mike. I'm glad you don't have to do this with relays. You know, I would think about how hard that would be. So, Ed, how about you?
Okay, all right. My name's Ed Henske, and I'm with Solaris. We're a multidiscipline engineering company up in Vancouver. We're 400 employees. We're mostly in the natural gas industry in British Columbia and Alberta. I help manage 100 electrical instrument and controls group. One of the challenges that I wanted to bring today is it's been very interesting. I've been in the projects for automation for 32 years. In the last 5 years, I've transitioned from being on the client side, helping to manage large projects, and I've moved now into the engineering world. It's been really interesting being in the engineering world because the tools that are available for engineering today are quite exciting. When you take a look at Aviva, you take a look at what the Bentley products are with 3D modeling, and also all the tools that you have for implementing a project, it's quite amazing what's out there. So the challenge that I've had in this being in the engineering world is how do I automate? How do I make configuring a PLC or DCS project, how do I automate that engineering? And you know, the base of engineering is P&IDs. That's where a project starts. So how do I take a P&ID and make that P&ID actually do the configuration in the PLC and DCS? And that's what we've really worked hard on in our project, because we know it's a real differentiator from us and our competition. And so we've actually taken the time to build the tools to be able to do that. So the nice part, again, is you take your P&IDs and you have your instrument index, your shutdown keys, and you have your motor lists. And you can get that all directly out of your P&IDs. The next thing is that, how do I take that and actually automate my PLC programming and also my DCS? And we've actually created the tools to do that. Now, one of the things that I'd love to see the suppliers do is that for us, what's really difficult is that suppliers provide some bulk edit tools, but they're very basic. And so what we have to struggle with is how do we make smart bulk editing tools to be able to make it so that configuration just happens. And so that's really the challenge that I'd like to make with a lot of the automation vendors is how can you help me to be able to go from a P&ID to actual configuration? And I know it can happen because we're doing it, but the thing is that because we have to create value for our clients, we don't have a lot of time to develop the tools. And so we're probably about 80% there. And I'd like to see the vendors come to the table and help me with that next 20% to be able to do that automation. And again, if I look at it, there's a lot of tools. It's providing the templates. There's a lot of things that we do in automation in the DCS that I want to see vendors coming to the table to provide the tools. Like everybody does first out logic, but why do we have to do it? Why can't the vendors have a lot of that stuff in their system? You know, the other is that bypasses on safety. Again, we've always have to develop those templates, and I'd like to see the vendors coming and providing those tools so that we can make it easier to go from P&IDs to configuration.
Okay. Well, thank you, Ed. Good to hear of some of the things that you could have that would make your process work a lot better. I'm sure a lot of owner-operators feel the same way, that tools that make things efficient certainly help a lot. Let me ask the audience, is there anyone that has a question they'd like to ask? This gentleman right here. And here's a microphone coming.
Hi. My question is related to advanced process control. I know in the petrochemical or refining industry, APC is fairly common. It's not a nice to have, but it's must to have. My question is for Alcoa and the power. How often do you use APC, or is it just starting out, or what are the challenges with APC in your industry?
Okay. Hello? Okay.
Try.
Hello? Sound works? No? Yeah. So a couple of things. I think the advanced process control that applies to process industries, again, as I said in my slides ahead, that for our refining operations, that's already built into the systems, and to some extent, even in the smelting operations, we have the traditional APC sort of built into those control systems. For the discrete manufacturing, particularly for the rolled products business, we use advanced controls in a slightly different manner. So if you look at rolled products where you have coils of sheet that are being rolled on a rolling mill, and you do your mill setup once in 5 minutes or 10 minutes. So in that sense, the advanced control comes in where we actually use physical models of the process that allow you to optimize your set points for the machine. And so it's a slightly slower loop. It's in minutes, not in seconds. And so advanced control to us in that arena means model-based control. And I think when we were talking about it earlier, it applies to the other processes as well. We haven't gone down that path as aggressively as in rolling. So for extrusion, forging, you could do something similar.
Yeah, we have advanced process control group in our engineering, and we apply in various applications. I think the key thing is that it's very important to have process and product understanding, and I think this really helps you understand your process so that you can run it faster, or you can use less material, and all those things add to the profitability. What we are trying to do is to escalate it further so that we can apply not just on specialized applications, but everywhere. Thank you.
Daniel?
Within the power industry, advanced process control in the past has not been utilized as widely. And one of the reasons for that, I believe, is there is some play in between the boiler or the heating processes and power generation versus the generation side of it. And so you can have extra energy that you can either utilize or absorb with the fuel process, whether you're looking at a nuclear plant that's making steam for a turbine, or whether you're looking at a coal plant. But in more recent years, as we've seen the power system be taxed a little bit more within the country, I believe we've seen more and more advanced process control, and it comes from things like when there's new steel mills or new aluminum plants or things like that are built. And the power plant may need to ramp more quickly to keep the voltage levels on the transmission systems where it needs to be. And so you need a faster response out of the power plants. And so it's being used more and more in that area. And the big challenge, I think, with advanced process control is figuring out whether you decentralize or centralize the support for those systems. They take a little bit more care and feeding than a lot of automation systems do. And in particular, model-based control, requires, some advanced knowledge of those models and things. So,
yeah. Mike, you want to add anything about the challenges of advanced process control?
So of course, we've had, in the petrochemical industry, we've had advanced process control for years. From my side now, the issue is that we don't actually always know how well they're working. Sometimes it's hard to tell. Many plants, the first indication of not working is the operator says, this didn't work. rather than you knowing in advance that it has been deteriorating over time or something else has changed. And so I think that's some of the things out there that we need to get a better handle of. And a lot of it even may be aligned with, here's how well it worked when I first put it in. It doesn't, like, you almost need kind of two measures. One is, when I first put it in, here's how well it worked. I'd like to at least keep it as good as when I first installed it because everyone thought it was working, it was doing the right thing. The second one is, what would a perfect controller look like? And that's more on the math side. How well does it work to perfection? And I don't think you can always get to perfection, but certainly you should be able to keep it running as well as it did before.
Thank you. Any other questions from the audience? Oh, right here. You, sir.
Hi, John Cooley, Procter & Gamble. I think my biggest challenge is managing user requirements, specifications, and software application designs. If I go to an end user, he'll write a Victorian novel to give to the system integrator. If I go to an IT guy, it'll be data flow diagrams and entity relationship diagrams. If I give it to a controls engineer, he may produce some sequential function chart, but I get this variety of requirements. How do you guys manage user requirements and specifications? Because whenever you document that stuff, it's got to go to the integrator. They're going to issue you a quote. They're going to design it, and then you're going to try and validate and test it offline. That, to me, is a big issue. How do you handle all those areas?
That's a great question. Anyone want to take a shot at that one?
Okay, so we do have, when we start the project, we have even Word document of project scope and how it will work out. And then we as we go through, we have e-matrix, so we do document all the drawings and comments. And now we also use programming software in which we write all the comments. And finally, when we are all done, we do create the engineer who does design pretty much write comments right wherever the programs are written. So they are there as part of the package. And they all are into a management of change system so that anybody who changes that will comment as to why he changed it and what really got changed. So we do have a management of change software where we deposit all this information.
Good. Anyone else want to comment?
So for the most part, it's the traditional, group of people that would go out and collect requirement specifications and go down the path that Ashok was describing. But of late, what we've been doing is to get over the hurdle of having requirements that are so different from the operating folks versus the IT folks. We are beginning to integrate those types of groups together in the requirements phase. So when we send our project managers to look at kickoff meeting, we have representation from all of those groups in that same meeting, so that when we list out the requirements, they're more integrated, and we are not throwing stuff over the walls to each other. So.
The other comment I would add on the power side is you see a lot of different utilities that do projects in different models depending on how much engineering they're doing in-house versus what outside engineering firms are they utilizing. And so that can change what that looks like a lot. In our case, we have kind of somewhat standard specs. If we're going to build a combined cycle plant or we're going to build a new coal plant or something, we have or put in a new, upgrade a control system or put in a new system at a plant. We have a pretty standard spec that we would use on that type of project. And the other thing that I think you see a lot in power is there's a pretty small number. If you start talking about large power plants, there's a small number of control system vendors who really are working in that market. And some of those vendors have seen over the last few years the challenges coming with the workforce, and many of them have invested dollars to develop standards and specifications for how to deploy their system in a particular type of power plant. And so working closely with vendors like that is a key thing, and hopefully not starting with a new vendor on every single project. If you can do a large number of projects over the years with the same vendor or with a small number of vendors who you've developed, standards with, and who has standards of how they do work, that's been a big piece for us, is partnering with vendors over time.
Ed, do you want to comment?
We had a challenge in that we were working with a client that had just done smaller projects, and now they were looking at getting into a project that was into the $25-35 billion in doing upstream gas projects. And so when we went to the user, they didn't really have a lot of specs within their corporation, and now we were in the challenge of how are we going to go through a process to be able to come up with what is the goal of the project and what are the user requirements for the project. And so what we elected to do is go through a selection criteria process. And so the first thing that we did is we found out who the key stakeholders were within the corporation. You know, we looked at the business analysts, we looked at IT, maintenance, operations, and production, and we got them together. And the thing that we first needed to do is to educate them with the technologies that were available on projects like this, because again, because they were in small projects, they weren't aware with all the technology that we're talking about in this 1 week. What we did is we hired a third-party company to come in and facilitate that process for us, and it was actually ARC Advisory Group that came in and helped. And I tell you, the side benefits that we got from this was amazing, because not only did we go through the selection process to be able to understand what it is that we wanted to do for this project, but the thing that was quite amazing is some of the side benefits. We were able to get people that really didn't understand what automation can do for a project, and through the training that we did, they really got the vision. And it went from when I first started talking about a lot of the things that we wanted to do, having very little support, but at the end of it, these guys began to see that the technology was going to make a really big difference. Now, one of the interesting parts is that going through that technology selection, you know, you're looking at the business requirements and you're really being able to tailor what are the objectives of each technology. And it was an amazing process that we went through, and it really helped us to define what we wanted to put together for this major project.
Thank you, Ed. Any other comments? Anybody else? No? Okay, I think unfortunately, we're just out of time. I want to thank the audience, and I certainly want to thank the panel for giving us some great insight into the challenges of automation. So let's give them a warm round of applause.